Thank you, Leon. My name is Michael Arnold, and I work with John Hart and Chintan Vaishnav, and we're developing a soil nutrient analysis system for smallholder farmers to enable them to improve their yields. So soil health is critical for crop growth. On the left, we see the effects of a nutrient deficiency on this corn. And on the right, we see what is possible with optimal nutrient levels. Now, to produce outcomes like we see on the right, it's necessary to perform soil testing. Because nutrient levels vary dependent on cropping history and management practice, it's necessary to measure the soil at each plot. Now, this image here is a context that many of us are familiar with and what primarily soil testing has been developed for. These center pivots are approximately 64 hectares. Now, this is a context which is extremely common throughout the world. And our 64 hectare plot encompasses a multitude of farms. So the average smallholder farm is approximately 2 hectares. And this comprises roughly 475 million smallholder or farms worldwide, or greater than 83%. And we need to develop a system which enables every one of these farms to test their soil. So site-specific nutrient management or soil test-based fertilizer schedules have been shown to improve yields and profit for farmers over their existing fertilizer practice. It's extremely common for nitrogen-based fertilizers to be over-applied and potassium or phosphorus-based fertilizers to be under-applied. And often, these test-based results produce an improvement in fertilizer use efficiency as well. Now, we primarily operate in India. And one of the challenges for farmers in India is that there is an insufficient supply of soil testing laboratories. So given the current capacity in the state of Maharashtra, if they were to test every farm, as would be ideal, it would take them approximately 10 years. And further, it's common for results to be returned to the farmer anywhere from 2 weeks to 6 months after they've submitted their sample. Now, this poses challenges because typically the farmer has already planted their crops and is well on the way through the season. So it's too late for them to perform or make any changes. Now, the solution that exists for field-based testing are these colorimetric kits. The challenge here is that the accuracy is extremely subjective. We see my friend Nikhil here trying to decide whether his phosphorus levels are sufficient or low or very low. And additionally, these tests are difficult to use. It can take anywhere from 2 to 3 hours to perform a test and involves many steps. So through many conversations with many farmers, we've arrived at these 4 key attributes for a system. Number one, the analysis needs to be performed on site. And this is crucial for a farmer to believe the results and adopt the recommendations. It needs to be easy to use so that a farmer without prior testing experience can perform a soil nutrient analysis. It needs to be accurate. Through conversations with agronomists, the test needs to perform plus or minus 15% relative to a testing lab for the results to be of value. And additionally, it needs to be low cost. The existing testing solutions are approximately $4 per test to the farmer. So we need to meet that or come below. So this is the system that we've developed. We enable farmers to test their sample on site and perform parallel analysis of nitrogen, potassium, phosphorus, and pH. And at the end of this analysis, a calculation is performed for an optimum fertilizer schedule, and we can deliver those results to the farmer through either a smartphone or an SMS message. Here's a video of it in operation. So we take a composite soil sample, which is an aggregate sample from many points in the farm, add that to an extractant solution. We take a ion selective electrode card, which is inserted into an electrochemical reader. This then runs a low standard calibration for 3 minutes. It's inserted into the soil sample solution and again performs a reading, which takes approximately 3 minutes, after which it is inserted into a high standard solution for the second point of calibration and 3 minutes, after which it is able to calculate the soil-based ion levels and deliver the recommendation to the farmer. So the key enabling technology here is printed ion selective electrodes. A traditional ion selective electrode can cost anywhere from $200 to $1,200. And we're producing the same results for a few cents in materials. Now, we have one electrode that we've developed for each of our target ions, and these, paired with an electrochemical reader, comprise the complete system. Mapping this against our key assessment of success, our system takes approximately 10 minutes to produce results. We've demonstrated with many farmers that without prior testing experience, they can correctly perform a test. The price is approximately $2 per test. And the accuracy, we've made great strides over the past year and are well confident that we can meet the plus or minus 15% target. So we have ongoing efforts, both in India and US, to calibrate the system and validate the results with respect to a soil library that's been characterized. We're working with collaborators at the Department of Agriculture in Maharashtra to perform this assessment, as well as Cornell University in New York. We have a field study planned for Maharashtra, and due to ongoing delays because of COVID, we have had to push this back to the next season, but we are optimistic to produce great results from this test. So with that, I would like to thank you, and please reach out to me with any questions. Many thanks.